Hi, welcome back to Calculus. Today we're looking at section 9.2, infinite series. An infinite series is just the sum of an infinite sequence. So you take all those terms in their sequence and you add them together. So to get us started, we need to talk about something called a partial sum. It's really hard to add an infinite number of things, but we can add a finite number just fine. So a partial sum is just the sum of the first n terms, and we're going to use S sub n to denote the sequence of partial sums. So given a sequence A sub n, the sequence S sub n is defined by S1 is just A1, S2 is A1 plus A2, and S sub n is equal to the sum from k equals 1 to n of the A sub k's. So again, you're adding up 5 of them, the first 5 terms, or the first 30 terms, whatever it might be. That's the sequence of partial sums. So then, now let's move this because I have a little bit more over here. Then we can say that if the sequence of partial sums converges to a limit L, then the series, the sum from n equals 1 to infinity of A sub n, will also equal L. And so this is our notation right here for a series. The sum from n equals 1 to infinity of the A sub n's. And if it does not converge, it is said to diverge. One last piece of notation here before I clear the board and start over. The sum of n equals 1 to infinity of the A sub n's is the same as just writing the sum of the A sub n's. If you just see this notation, the sum of A sub n, it is just assumed that it goes from 1 to infinity. All right, so let me clear the board and do more. So let's continue on. Let's very specifically look at something called a geometric series. So a geometric series takes this form: a plus a times r plus a times r squared, and on and on and on. So this would be the same as the sum as n goes from 1 to infinity of a times r to the n minus 1. That's because 1 minus 1 would give us 0, so we'd have a 1 out of that, which would just give us that a for that first term. Or you can write it as n equals 0 to infinity of a times r to the n. It really doesn't matter. You're still starting in the same place. But importantly, r can be either positive or negative. And so what's nice about the geometric series is it's really very straightforward. If the absolute value of r is less than 1, the series is always going to converge. And it converges to this. The sum n equals 1 to infinity of a times r to the n minus 1 is just a over 1 minus r. Guaranteed. Done. And if the absolute value of r is greater than or equals 1, it always diverges. So you can see I have an example here where r is negative 1/3 and a is 2. So we could generate this sequence if we wanted, but what we're really interested in is figuring out this sum. So it's a geometric series, so I plug in my a and my r, and you can see I have the sum from n equals 1 to infinity and n minus 1. So I just plug it straight into that lovely old fraction that we had there. My a is 2, my r is negative 1/3, so I get 2 over 4/3, and if you clean up that mess, you get 3/2. And then I have another example over here. We're going to take a repeating decimal, and we're going to turn it into a fraction. So I want to write this decimal 0.234 as a fraction. Well, the important thing is that the repetition here comes in groups of 3s. So since we're working with decimals, 10 to the third is 1,000. In other words, this is the thousands place. So three decimal places. So my 0.234 could be written as 234 over 1,000. That would be the first 3 places. The second 3 places would be 234 over 1,000 squared. And so we can see, and if you kept going, you'd have 1,000 cubed, 1,000 to the fourth, and so on, which really makes it look like a geometric series. And it is, but we have to be a little bit careful here. The 234 is not being raised to a power each time, so it doesn't get to be part of our r. Instead, I'm going to pull that out and use it as part of my a. So I factored out 234 over 1,000, and then I have a perfect geometric series. What I'm left with is 1 plus 1 over 1,000 plus 1 over 1,000 squared. I guess technically I should have left the 234 over 1,000 out front, because really the geometric series is just the 1 over 1,000 with an a of 1. So anyway, I have 234 over 1,000. My A is 1. My R is the 1 over 1,000. And if you clean up that mess, you get 234 over 999. And that does actually reduce. I just didn't bother to do it. But there you go. We can turn it into a fraction. That's pretty fun. So let me clear the board and get more. All right, so finishing up, we're going to start this last board with a theorem, a very simple theorem. If the series converges, the sequence has to go to 0. Just has to be the truth. And the contrapositive also works. The contrapositive would say if the sequence doesn't go to 0, then the series doesn't converge. And that's what our nth term divergence test is. It just says the series from n of the sum from n equals 1 to infinity of a sub n diverges if the limit is not 0. This limit of the a sub n, it could be infinite, it could be negative infinity, it could be 7. It doesn't matter. Basically, if you keep adding things together that are not 0 or not getting very, very close to 0, you don't get convergence. And so I did an example here. The sum n equals 1 to infinity of n to the 4th over n to the 4th plus 5. It does diverge, and we can see that by taking the limit of the terms. As n goes to infinity, what we can do is, again, I'm going to divide all those terms by the biggest power there, n to the 4th, which gives me the limit as n goes to infinity of 1 over 1 plus 5 over n to the 4th. And 5 over n to the 4th, that goes to 0, leaving me with just 1 over 1, which is 1. And so since the limit of these terms is 1, what that means is this has to diverge. Because basically what's happening is as you keep going out farther and farther, you're really just adding numbers you're really just adding a bunch of ones. And if you add up an infinite number of ones, you get infinity, and that's certainly divergent. So let's move this down. Almost done. We have a theorem. If the series A sub n is equal, sum adds up to A, and the series B sub n adds up to B, if these are both convergent series, then their sum and differences are convergent, and will just be A plus or minus B. So if you add them together, you get A plus B. If you subtract them, you get A minus B. And constant multiples can be pulled out. So the sum of K times A sub n is K times the sum, and that's just K times A. And last but not least, two things. Every non-zero constant multiple of a divergent series has to diverge. Okay, it doesn't matter what you're multiplying those terms by. Those terms the series is adding up to something infinite. You're adding a lot of numbers. You're adding an infinite number of things. So even if you multiply them all by 1/1000th, eventually gets big enough that it's too big. And if you have one convergent series, so the sum of A sub n converges and the sum of B sub n diverges, well, when you add or subtract them, it's still going to diverge. Okay, the divergent series wins. So there we go. There's our introduction to series. Have a wonderful day.